Okay, so now you can see me. So hi everybody, I'm Carmen, and this is.
I'm Remco. Hello.
And we're both colleagues at ING. We're working together, and today we want to speak about web components. And our talk is entitled "The Magic of Web Components," because we like very much the Disney cartoon called "The Sword in the Stone." So that's going to be our theme for our talk.
Okay. Well, I'll just start with just describing how does a normal, an average HTML structure look like these days. There's a lot of diffs nested inside a diff, nested inside another diff to make something visible on the screen. Doesn't have to be a diff, but you get the point. So basically the sugar is like the diff. We just want to put more diffs inside our DOM, and yeah, it becomes a bit much. We can add more, keep adding more, and in the end, we end up with something like this. We're really happy it's working, but the DOM really looks, crap, basically. There's a lot of stuff in there, a lot of HTML elements, and to look at it, it's really complex if you don't work on it and you don't know exactly what's happening where. That's why web components have been invented, or are being invented as we speak, actually. In a nutshell, basically what it says, it's becoming a standard that allows us to encapsulate and share reusable widgets. The idea is, as I said, is to isolate a lot of the markup. So you won't get the bloated diffs or a lot of diffs inside your HTML. It will just be a really nice small part, and you can share them, etc. on the internet really easy, because it's really easy to use them. They're still being developed. Currently, the specs aren't stable yet. We'll get to that later.
So let's have a look at what the standards are, because web components is basically an umbrella term for 4 different technologies. The first one is custom elements. It's kind of what Remco explained, that you would just have these like very nice to look at elements that you can reuse all over your app. Then we have templates. There's Shadow DOM, our favorite, and there are also HTML imports. So these are the 4 specs that we're going to talk about. Let's start with custom elements. So custom elements will allow you to extend HTML. That basically means that you will be able to teach HTML new syntax, new components. You will extend the HTML vocabulary with elements that you are going to create yourself. And these elements, or these DOM elements that you're going to create, they're going to be fully featured, and you are in charge of deciding how these elements will behave. So for instance, you could create an element that would look something like this. And this element would basically encapsulate all that div soup that we showed you at the beginning of the presentation. So why would we want custom elements? Well, they're basically 2 words to describe why we would want that. And that's sexy markup. Okay, so I'm kidding a bit. That's not really the only reason why we want custom elements. Custom elements will give you a declarative and readable, as in very readable, meaningful, reusable, self-sustainable HTML elements. And this is like a milestone in a way, because this means that when you're looking at an application, you could basically see what the application does just by reading the markup. And that's actually quite powerful. You won't get lost in all the implementation details. That's probably, as a consumer of the app, you're probably not interested in that. So there are a few things that we need to know about the custom elements. Custom elements have this thing that is called a life cycle. And the life cycle of a custom element is comprised of registration of the element, then instantiation, attaching and detaching the element to the DOM, and then the attribute changes of that element. So let's have a look at the custom element registration. Registering a custom element means basically that you're going to add the element definition to a registry. So let's explain a little bit about that. The element definition is comprised of a few key parts. One of it would be the type of the element that you're creating. Also, the element needs to have a prototype, so it needs to inherit from an element, from another native element. And then there's also the lifecycle callbacks, where you can, depending on the state in which the element is, you can add custom behavior to your element. And the registry is basically, it's a set of element definitions, and that's associated to a document. So what basically happens is you have your document, and that document has a registry attached to it or associated to it. And whenever the parser parses the DOM and it finds an element definition, it will take that definition and it will register it in the registry. So when that element needs to be instantiated, the parser will know where to find the definition, and it will also have, basically, it will know what behavior that element has. So in order to register a custom element, the document interface has been extended with the register element method. And this method takes the type of the element that you're creating, and it also takes an options object where you can declare several things. I have a very basic example here. I'm just registering the Merlin custom element, and you can see that the prototype is just an HTML element. So basically, my custom element just inherits from the native HTML element. Right. It's important to note that register element will return the constructor function. So then when you want to instantiate this element, you can just, for instance, call new and then the Merlin, and that will instantiate your object. Another very important note here is the naming convention for the type. If you're creating a custom element, you need to have the dash over there. Because the parser, when it traverses the tree, it will take each element and it will recognize that this is a custom element by finding that dash there. If your dash is not there, and if the element is not a native element, then that element will be resolved to an HTML unknown element, and then nothing will happen, basically. I see a very confused face there. That's how the specification defined it, basically. Because like otherwise, so there are a few reserved names, for instance, that a custom element can't have. I don't know them by heart, but if you look at the specification, you will see them. But this is basically the convention that was adopted. So if you have that the dash there, the parser will know that it deals with a custom element, and then it will go in the registry and it will look for its definition.
Basically, they're leaving out the non-dash words for the vendors itself. So later on, if Google or whatever wants to initiate an extra HTML element to Chrome or whatever, they can call it Merlin, for example. If we take this example, they are reserving those slots specifically for their own elements.
Yeah, that's actually a good point. Right. There's also a few other things that you can do with custom elements. So for instance, you could expose public APIs for them. So for instance, in this case, I'm inheriting from the HTML element, and then on top of what like all the APIs that I get from the HTML element, I'm also declaring my own. So for instance, I'm declaring a cast spell function, which just simply logs something, but this will be available for the consumer of my element. And this is, yeah, it's basically just a public API. There is one important note here. There are two types of custom elements. There are custom tag elements and there are type extension elements. The difference between them, well, you'll see it better when we're going to go into instantiating the custom elements. But basically, a tag element can just be used as such, so it will just be a tag in your markup. Whereas the type extension element, it will extend an existing native element. So for instance, in this example, I'm registering the Merlin, a custom element, And then below, you can see that Magnificent Merlin, it extends the custom element that I declared before. And then you can see that in the extends keyword. There's also a semantics difference between the two of them. So when you're declaring a tag element, if, for instance, I would have a taco button, it doesn't mean that that element needs to be a button. It doesn't have to have the semantics of a button. Whereas if I would declare a type extension element, it would have to keep the semantics of the element that it's inheriting from. So how do we instantiate these things? Well, for custom tag elements, it's just what I said. It's just a tag in our markup. But you can also instantiate them using JavaScript. So document has this create element API, and then you could just invoke that. Or, as I said, you can call the new operator because the custom element registration returns a constructor function. So then you can use the constructor function to instantiate the element. And for extension type elements, you have the is keyword here. So you can see that I'm using the custom tag element, the Merlin, and then the Magnificent Merlin is something that I'm passing to the is attribute. So this means that I have the Merlin element, which has something on top of that. You can also use JavaScript just as for custom tag elements. So the same, like document create element, and then just, or call the instantiate it, calling the constructor function. The lifecycle callbacks are these four. So you have the created callback. This is called when the instance was created and the definition was registered. It's very important to remember this because it can happen that the parser will attempt to create an element before its definition was registered. And this can happen because of the JavaScript execution, so the order in which you include your scripts in your markup. There's also the attached and the detached callback, and these are called when the element was inserted or removed from the document. And there's also the attribute changed callback, which is called whenever an attribute that is declared on your custom element has changed.
Now I'll take over for the templates. That's another one of the web component, well, parts, basically, if you can describe it like that. What are templates? Well, we know them in other languages already, and basically you can store a small piece of data inside another document. It's called a document fragment, but let's just see it as another small document. We can already insert this into our own HTML documents, etc., but it's not loaded yet or started yet. Basically, images aren't loaded yet, the scripts aren't working yet, there's no styling, etc. That will start at the moment when you initiate a template, basically, when you load it, basically really load it into your into your app. And why do we want them? Well, we want to have separation of concerns. We don't want to put styling for a certain button that is only used in a specific slot into the whole web page that makes up and breaks everything. Another one is it's really clonable. We'll see later in how you use templates. You can just clone an element, a template, and use it wherever you want in the page. And very important to remember, it's parsed as HTML because it's just an HTML document, basically. It's not rendered till it's cloned or appended to the body. It can be cloned, that's really important. And it's instigated at runtime when the user wants it. It's not really at the start. So you can really control when this button is active or not active. So how does a simple template look? We just start with a new element called template. We give it an ID that's basically the name of the template. So it has to be specific. You can't have multiple IDs for one page anyway. So you have to be a specific element, ID. We can have style in it. We can just describe our own style in it with whatever you want. We can have our own, basically the markup in it. So all the diffs, the spans, whatever you want it. We can make it as big as we want. We can put as much sugar in the cup as we want with this as well. But we have these templates for a reason to not do that. And we can have our own script in it as well, which is won't load till it's instantiated on the page. So how do we enable this, actually? We're already a little bit ahead of the presentation because we will get to the shadow DOM later, but we are creating it here already with the create shadow root function. That's basically the root of where the template will be in the document, but we'll get to that later, how that really works. We have to import our own template with a query selector, for example, in my example, the example template, and we have to clone it. Then it's not yet on the page, basically. We have to append it to our shadow root or to our document, whatever we want to do. At that moment, everything in that script or in the page will be rendered and used, and it's basically on the page then. Till that moment, there's nothing. We can put CSS in it in different ways, just the normal span, make it red, or whatever color you want, of course. But sadly, link doesn't work. So we can't say, well, I have this amazing style sheet, and I want to use it in my templates. So I can put it in different places, etc. There's a reason why people use CSS templates, CSS files, because they don't want to rewrite their styling every time or copy-paste in all the HTML documents they use. Luckily, the add import class does work in the templates as well. So we can still do it in kind of a, maybe you can call it a hacky way. But at the moment, that's the best way. I don't know why link isn't in the specs. They don't want it at the moment inside their templates. Why, I'm not entirely sure, but hopefully we get some well, results for that as well. But in the meantime, this works in all the browsers, unless you work in Internet Explorer 5 or something, but let's hope no one uses that anymore. Yeah, this is basically the shadow DOM. It's also called, it's basically shown as the mean guy of the web components. It's mostly used as the, or associated with, it's the most difficult one to grasp why it's working, but it's really important for the web components. And there's a lot of discussion currently between the vendors on what they can do with it and what they can't do with it, basically.
And this also gave us a lot of headaches in the demos that we have in our presentation. It was the one that gave us the most headaches because it's like some vendors support it, others don't. You'll see. We'll show you. Yeah.
You'll enjoy it with us. What does the shadow DOM basically do? It's basically, you have the normal DOM, which is mostly referred to as the light DOM these days. It's just your normal HTML, head, body, etc. And the whole DOM tree with how the nodes are connected, etc. The shadow DOM is, well, in theory it's basically the same as also a tree of nodes, but it's on its own. So basically it has like a magic field around it, and it's blocking everything outside of it. So basically, as it says here, it encapsulates and hides everything that's inside the shadow DOM, basically, to his surroundings, his parents, etc. Why do we want this, do we think? Why would we hide stuff from the rest of the document? Is this really smart to do? Well, sometimes, as I said before, the templates as well, you want to have styles. You want to use a specific style sheet from a different website. Instead of Bootstrap, you have other ones, etc. You want to combine them, and you want a specific style for that one button. Now, normally, you have to write really specific selectors in your CSS in order to get that button to show up as red, for example, and all the other buttons as blue. With the shadow DOM, you can just say, I want all the buttons in this shadow DOM to be red. And all the other buttons that aren't in the shadow DOM won't know this and won't react to it. So there's a really good style encapsulation. Script scoping as well. You basically, the scripts inside of the shadow DOM can't be used by the stuff outside it and the other way around as well. They won't react to it. And again, separation of concerns. You want to keep, a web component wants to be on its own and doesn't want to be interfered by the rest of the page, basically.
I actually have a very good analogy for this. I like to call it what happens in Vegas stays in Vegas.
Just a few concepts to see for the later explanations, because it's the hardest part to grasp. We have some concepts. We have the document tree, which is the normal light tree that the light tree, yeah, what I call it. It's basically node tree whose root node is the document. So basically the normal DOM as you know it. Then we have the shadow host. The shadow host lives inside the document tree. It's not part of the shadow DOM itself, but it's the connection to the shadow tree. We'll see in a picture later how this works. We have the shadow root, which is basically the same as the root node of a document, but then of the shadow tree. And the shadow boundary, which is basically the invisible magical field around the shadow DOM. So basically this is a small overview of how it would look. On the left you can just see the document tree, the light DOM, and the circle on the left top is the shadow host as well. It also has normal child nodes, but it also has one of those nodes is a shadow node basically of a shadow tree. The other childs don't know this, but it's there as well. There's a connection. And when you go to rendering, because basically when a DOM renders, it forgets about shadow trees, but it has to render the shadow trees if you have activated it, because you want to have it on your page, because else it's useless. So basically the shadow host represents the shadow root in the rendering process. The shadow root is never rendered, it's not there. That's why it's also displayed here as a square. All the circles are rendered during the rendering of the DOM. As you can see in this image, it's basically the shadow root is gone, basically. We don't want that, it's just there to connect the shadow tree to the DOM tree. So how do we activate the shadow DOM? As you've seen in an example of the templates as well, we basically just have an element which is the shadow host, so we can take a div or whatever we want, where we can put it on, and then create the shadow root on it. There's one variable that we can pass along to this shadow root. It's relatively new in the specs. It's because a lot of the vendors have been arguing about this. It's called closed versus open. It doesn't come to a surprise that Google is on one side and Apple is on the other side, if you look at the history of how these companies have worked in the past. So basically you have two modes now, open and closed. I'm sure you can guess that closed is from Apple, because they want to hide everything and they're strict. It's their thing, it should work on its own, and other developers shouldn't be able to change this, because the person that made this knows what it's doing and knows how it should work. And open is for Google. They want to have you should be able to interact with it. So basically in the closed mode, you can't do anything with the DOM. In the open mode, you can interact if you know how to interact with them. You can change a lot, but you can put things in there that you can say, well, the real document, the light document, can talk with the shadow root and get some information out of it. Not a lot, but some. It's basically, if you compare the input type date, which is currently already used, which also uses the shadow DOM already for a while, and the video, for example, they're all closed. You can't interact with them. So basically, those use the shadow root closed node already. There's one more thing. Sometimes you're like, well, I want to be able to put some information from my light DOM inside my shadow DOM. And you have to be specific about it. The developer that made the web component with the shadow root has to allow this, basically. So that's called slots. It used to be, for people that already know some about web components, was the content, sorry. But they changed it recently to slot because apparently content was, well, they didn't agree on it, and slot has been replaced by it because it made more sense to a lot of people. So basically in the document tree you can have some childs that you're like, well, this text, I really want this to be visible inside the web component that uses this shadow root. And you have to say, well, I want it on the spot that's called slot test1, for example. And the shadow root has to specify where this element will show up and has to name this element as well. If that doesn't happen, it's not working. So for example, in the shadow tree, we have to say, well, I have this slot called example, and whatever the other user that uses this web component can be placed inside of this. And in document tree, you can just say, well, I want my example text on that specific spot. So I call a div with slot is example, and that one will render on that specific spot.
So, and then last but not least, there are the HTML imports, which basically kind of glue all these technologies together and make them reusable. So HTML imports are basically a way of including an HTML document into another HTML document. And why is this important? Well, because if you look at what we currently have, most of the content that we have on the web has a declarative way of loading itself, except for HTML. So for instance, for JavaScript, we have the script tag, and then for CSS, we have the link tag with the style sheet rel attribute. For videos, we have video, and so on and so forth. And then for HTML, we basically have, we have iframe, which I'm sure everybody likes to work with. There are also a few other hacky ways to go around that, but there's basically no nice and clean way to do this. And this is what HTML imports try to solve. So how do you declare an HTML import? Well, it's basically, it's just a link as well, but then the rel attribute has to be set to import. And then the href will represent or needs to point to the HTML that you're trying to include in your HTML. There are a few important concepts, just like with shadow DOMs, like a few terms. The first one would be the import referrer, and that is basically the document that links to the import. So, for instance, in our case, if we declare this, this link in our index.html, then the referrer will be the index.html document. There's the import location, and that's the URL of the import, so that href attribute, that's the import location. There's also the imported document, and this is basically the document that represents the import. I'll clarify this for you in a second. So it's very important to remember that when you declare that link, so when you are using the HTML import, what you will get back is the document itself. You are not getting the content of the document. In order to get access to the content of the document, then you need to use link.import, and that will give you access to the internals of the HTML document that you're importing. And in order to do that, you're using query selector and then just .import, and that will give you back the content. So let's talk a little bit about browser support, because in main lines, this is kind of it. Like, this is what web components are. But the idea is that I know also from experience that browser support is the most scary thing about these things. And I also know that this is kind of the thing that holds most of the developers back in using them. So in like a very nice picture and in a very, how do we call this? Like magical world. It would look something like this. Which is, it's not super bad. It's not like super good either, but it could be worse, right?
Yeah, it could be. Well, before last week, Safari was still red on the bottom as well, but it's getting there.
Yeah.
But this picture sadly doesn't represent the real truth. Yeah,
as we found out. So there have been some changes to the specification, and it's a bit confusing, I have to admit. Like 1 year ago, I was talking about this, and back then it felt that the scene is a bit more stable, whereas now it feels that it's kind of all over the place because of these changes. So there's something very paradoxical happening at the moment. So there are vendors that are kind of not supporting major parts of web components, but they're supporting the new additions to the spec. So for instance, with Safari, Safari is like Safari, right?
Yeah,
Safari Nightly was
released, I think, the 12th of November. Well, basically this week.
Yeah, it was relatively new.
Yeah, with the slot functionality in the Shadow DOM. They didn't have the Shadow DOM before that. Google had it, Chrome had it, and which was the other one?
I think Opera.
Opera had it.
Yeah, because they work on the same.
Safari didn't have it yet, but they released a new patch for their nightly build, and they had the Shadow DOM with all the new calls, with the slot functionality, etc.
Exactly.
On this picture, which we got this morning from webcomponents.org, basically what do you call it? Like the share, where it shares the newest updates of web components, or it should. It says that the Shadow DOM is green, but it doesn't have all the new functionality yet. It has a Shadow DOM, true, but it doesn't have all the functionality yet. The only one that is really, the only part of web components that is like set or fixed are the templates at the moment. The rest are still being discussed on some points, but along the way, some of the vendors are already implementing these things. But sadly, it's a changing world, and they still have been changing some things on the specs as well. And vendors are basically trying to pick up. Edge is, as you can see, the slowest one, but that makes sense because they're still building on some of the functionality of the normal functionality of web browsers that other browsers already have.
And I think like one thing that I want to point out here is that out of all the web components, like out of the 4 technologies, templates are the one that actually made it to a standard, to a fixed standard. Everything else is in draft state, but templates are a standard already. Right, so there's a bit of a community evolving around web components. There are a few libraries and polyfills, and I'm quite sure most of you have heard about Polymer. There's also Xtag, which is a project from Mozilla. And do you remember how the third one was called?
Yeah, Bosonic.
Yeah, that one was new for me. I didn't know about that one. I also haven't like really looked into it. I did, however, look into the web components polyfill, and that actually kind of does the trick. So all of our demos import this polyfill in order to make them work all over, like across all browsers. Yeah.
It's basically the polyfill just fills in parts of the web components that aren't there yet in the browsers, and they're trying to keep it up to date as soon as possible. If they change something in the spec, they'll implement it in the polyfill as well. So you can, for example, on Safari, which doesn't have custom elements yet and HTML import, you are able to use those features because it's in the polyfill, basically.
Yeah. Right. Do we still have time for a demo? I think we do, right?
Yeah, let's go for it.
Okay,
I didn't see anyone, so.
So we made like this very tiny demo that fits with the atmosphere of it all. So let's have a look. Do we want to show the code? I guess so. This is going to be interesting. Wrong project. Nope. No. Here it is. You see? Yeah. Okay. Can everybody see this? Yeah, but this is a very, very, very old WebStorm version. So. But this should be fine, right? Okay. So let's have a look. We made a custom element called DomCode, and like what it basically does. Let me show you how it's called here. So this is the main index.html file. This is where I'm instantiating the custom element. It's called it's just a simple tag custom element called DomCode. And then the implementation is basically kind of, it's a sum of everything that we've seen until now. So as you can see, I'm declaring a prototype here, so my element inherits from the HTML element. And then on this prototype, I'm hooking into the create callback, which is one of the callbacks, the lifecycle callbacks that I showed you before. And then in this callback, what I'm doing is I'm creating a shadow root, and I have this template, which I have declared here. So in this template, you see that I have some styling. It's just basically some animation stuff. And then I just have a simple div with some content in it. That's my template. So what I'm doing here is I'm selecting the template by its ID. And then I am cloning it because, like Remco explained, we need to clone that template in order to append it to our to the document. And then I'm just merely adding this template to the shadow root element. And then at the end, I'm registering this element with the prototype that I have defined. So that's pretty much it. It's like very simple, but it kind of encapsulates like all the terms that we have discussed until now. And it's just used like this, and that's it. And you can see here that we're using the web components polyfill that we mentioned. And then in order to use this element, I'm importing it. So this is an HTML import. You can see that by the rel attribute here. And then the import URL is basically points to the HTML where I have declared my element. So let's have a look at how this looks like. Let's see. Ta-da! So this is supposed to be the big Dom church. It's a bit crooked, but well, I think it works for now. It's something, yeah. So that's pretty much it, I guess. Do you want to demo something else?
I think we should show the shadow DOM with the slot functionality, maybe.
Yeah.
So just make it a bit more clear what the slot functionality actually is doing.
Sure, go for it.
We also made a. Let me show the code first. It might be better. What's the template? No, this one, this version.
It's command and then this, like this.
Yeah. So basically, what we have in our normal HTML, we have a div with a URL and just a list of quotes or stories, what you want to call it. And we have some quotes that are part of that are from Merlin, and some that are from Archer. So we basically want to separate them. We want to have a list of quotes of Merlin and one of Archer without having to do that inside our HTML. Because if we have a database, for example, or whatever, some backend feeding us these quotes, we want to be able to just have to adapt. Every time we make something, we have to list it or order it or whatever. So basically, we can use the slot functionality to do that for us, which is really basically, it doesn't scroll down, there we go. What we're doing here is for when everything is loaded into the DOM, we look for this element. On this element, we're going to create a shadow tree. In the shadow tree, we're basically checking, because of the fact that I made this before we had polyfills, we have the new way of calling it with attached shadow, which is basically the new one. I think we mixed it up in the slides, but that's okay. That's why we show this. And the older version, which was called create shadow root, which is usable in Chrome, etc. Sadly, slots aren't used in Chrome yet, so we can't really use it there, but it's ready. Basically what we're doing for Archer and for Merlin, we're making a new story group, quote group, whatever you want to call it, and we're creating a div. And in that div, basically we have the name of the element, so basically Archer of Merlin in this case, and the slot, which is also a unlinked list. That's all we have. We append it to the shadow root, and that's basically our shadow root. That's all we do. So basically what we're doing, we're transforming this list of quotes to a sorted list of quotes with the use of a shadow DOM. And the result is this, basically. And what was the button again to show this? There we go.
You can also right-click now. It works. Yeah, we had to
Technology.
we had to figure out DevTools for Safari.
So basically what we see in our diff is still the unsorted list, even though it's really sorted now. In Chrome and maybe Safari nightly as well, but I'm not sure where it is, you can basically show the shadow root as well, so you can look into it, but you won't see these texts. It won't be there. You'll just see a unlinked list with nothing in there. And to show you, well, yeah, I think that's it. We want to show it in Chrome as well, but we won't see much.
Yeah. Well, we can show, actually. Let's see where Chrome is. Oh yeah, this is C. And I can add a new tab and I can run it from here. It was Shadow DOM, right? Insertion.
Yes.
Ta-da! So this one doesn't work.
But if you look at the element now, because Chrome has this functionality, you can see the shadow root.
Yeah.
You basically see that even the light tree is called the shadow root according to, well, the inspector. It's not really the case, but yeah. And basically what you see in the shadow root is a diff with Archer, which is basically empty with a slot in it. So basically you can see in the inspector these days, you can see what's inside the shadow DOM. You can't interact with it, but it's there for you to see if you want to see if there's a slot or something like that in there. I think that's about it, right?
Yeah. So I'm going to give you the link of where you can find all these things, and you can just, it's a GitHub repo, and you can just clone it and play with it, and that's fine. I think that's it. Thank you. So just before you go, because I promised the link, it's this one. So it's just on GitHub. I'll tweet it out, and you can find it there.
Are there any questions?
Yes, questions. I think they need a mic.
Well, this adds actually value to the semantic web, because if you look at our few of the first slides, oh wait, we can do this quicker.